the WRI team, led by Dimitris, to start the webinar.
Excellent. Thank you so much, Tom. Thank you, Patrick. Thank you so much to the president and the director of the capacity building team. It's really wonderful to be with colleagues today. Allow me to share my screen. My name is Dimitris Mentis, and I am the lead of the Energy Access Explorer initiative. Sharing my screen, please do let me know once you're able to see the screen.
Yes, we can see it.
Excellent. So some of us are familiar with the term GIS, which stands for Geographic Information Systems. But all of us are benefiting from GIS systems on a daily basis. I think all of us are using Google Maps or Google Earth rather frequently, right? Imagine how great it would be if our community and if the beneficiaries of energy access were to have access to a digital public good which can help us deliver energy transitions for everyone, especially the unserved and underserved communities in the global south. Last week, the latest SDG 7 tracking report was released. We are going backwards. Yes, there have been some great anecdotal successes where we are able to expand access to energy services in certain communities, but the number of people without access to electricity and without access to clean cooking fuels is going up instead of down. Specifically in sub-Saharan Africa, the number went up from 560 to 570 million people with no access to electricity. And when we talk about the access to polluting fuels for cooking, the challenge is almost twice as large. Now, energy is, as all of us know, a critical enabler for socioeconomic development. We need energy access for improving healthcare. We need energy access for improving education. We need energy access for improving livelihoods, agriculture. Energy is interconnected with all development goals and with the vast majority of development targets. In order to address the significant energy access gap, the growing energy access gap, we need to be able to understand where the unserved and underserved communities are. And we need to be able to assess and identify viable ways to provide electricity, provide access to modern energy services to these communities. In other words, we need to be able to conduct integrated energy planning. We need to be able to conduct inclusive energy planning as well. I will leave these two definitions in the slide deck for everyone's reference, but I'd like to take you briefly through the three main reasons that led us to the conceptualization, design, and development of the Energy Access Explorer. Reason number one, there is an important need to treat demand and supply as equal. The vast majority of the planning solutions in the energy access space have been focusing on the supply side. What is the cost optimal way to provide electricity to unserved communities? Shall we extend the grid network? Shall we set up mini grid systems? Shall we set up solar home systems? There have been a few initiatives that are looking only at the demand side. If we don't understand aspects of demand, aspects of affordability from the bottom up, the supply strategy that we are designing will not be viable. Neither for consumers, whether these consumers are households or institutions, nor for the energy service providers, whether these are the main utilities or mini grid developers, solar home system providers, clean cooking technology providers, providers of PUE equipment, productive use of energy equipment. So we do need a platform which synthesizes granular data on both demand and supply and enables stakeholders with different perspectives to identify priority areas for energy interventions. Demand for energy. Where do we see demand for energy? In healthcare facilities, to refrigerate vaccines, to provide lighting to operation halls, energy in education facilities, ICT infrastructure, energy in households for lighting, cooling, cooking, heating, energy demand in businesses. That's the very first reason that led us to the conceptualization, design, development of the Energy Access Explorer. So similar to most industries, similar to most products, we need to understand first the demand before we design supply strategies. The second reason, there is a need to reduce reliance on GIS, Geographic Information Systems, and programming expertise for data and analysis users. The vast majority of the users in this space, the stakeholders in this space, do not have GIS and programming expertise. Same applies to most people in the globe. We do not have the GIS and programming expertise to be developing maps that can show us the path to reach certain destinations. But we have Google Maps that we are using. We would like to develop an equivalent that the community, the energy access community, and the beneficiaries of the energy interventions can utilize to identify priority areas for energy projects. So how can we reduce reliance on the otherwise resource-intensive GIS and programming expertise for data and analysis users? And you can say, Dimitri, WRI team, what are you talking about? You've been spending 15 years working at the intersection of GIS and programming and energy systems analysis and energy planning. You did your PhD in geospatial electrification modeling, and now you want to reduce the reliance on this type of expertise? It sounds counterintuitive, indeed. But we need to keep in mind that planning agencies, we need to keep in mind that clean energy businesses, we need to keep in mind that finance institutions, departments in the health, education, agriculture sectors with limited or no GIS capacity in-house should still be able to generate a customized analysis. So here we are speaking about data users. We shall not forget data providers. And coming to the third reason that led us to the Energy Access Explorer, because we need to think about the entire data value chain here. And data providers, colleagues, need to deploy an open source dynamic information system. Why? To reduce software engineering costs. Someone may say, why open source? Open source refers to the infrastructure, refers to the programming code. It means no licensing, no subscription fees whatsoever. Data, however, can be either open access, if their license allows them to be shared in the public domain, or password protected. So let's be mindful of the distinction between open source software, no subscription, no licensing fees, and data, which means which can be either open access or password protected. These were the three main reasons that led us to the Energy Access Explorer. And our vision is to provide geospatial data, geospatial technology, and create a future where both people as well as institutions have access to reliable modern energy services for achieving socioeconomic development. So energy access is not the end objective here, colleagues. It's, however, an important means to achieving critical development outcomes on healthcare, on education, on livelihoods, on agriculture. What is the Energy Access Explorer in a nutshell? It is the first open source interactive geospatial platform which synthesizes granular data on both demand and supply. Remember the first reason that led us to the Energy Access Explorer, treat demand and supply as equal, and enables stakeholders with different perspectives to identify priority areas for energy interventions. It functions also as a dynamic information system for data providers. The third reason that led us to the Energy Access Explorer, deploy an open source dynamic information system for data providers. 4 audiences and associated use cases. First of all, planning agencies at both national and subnational level utilize the Energy Access Explorer to inform integrated and inclusive energy plans. We'll speak about specific examples in a while. Businesses, clean energy businesses, can be mini-grid developers, solar home system providers, clean cooking technology providers. With no or limited market intelligence capacity in-house, should still be able to benefit from geospatial data and analytics and identify market opportunities. Where are our customers likely to be located? But we see even the larger businesses in this space benefiting from the Energy Access Explorer because it saves them a significant amount of time when it comes to pre-screening candidate locations for energy interventions. Finance institutions, where shall we allocate our grants? Where shall we allocate our investments to ensure the maximum impact? And finally, departments in the health, education, agriculture sectors to get an initial understanding of energy needs associated to development services. Think, for instance, of a health ministry. Here comes a sample of the Energy Access Explorer developed in Uganda. Later, my colleague Douglas is going to take us through a live demonstration of the Energy Access Explorer developed for Kenya. We start with the demand side. Data on population density, socioeconomic activities, education facilities, healthcare facilities. Here we get a national level overview of the healthcare facilities in the country. As a user, you can click on a facility and read information about different attributes, the type of the facility depending on the services they are supposed to offer, the name of the facility, the electrification status, catchment population, etc. As a user, you can utilize the satellite imagery, which is being updated on a daily basis to assess the situation on the ground. Zooming out, another important indicator on the demand side, agricultural activities, which are critical for socioeconomic growth in the region. Switching to supply-related indicators. Again, this is just a sample, colleagues. There are several more indicators in the online interface. Energy resource availability on the supply side, global horizontal irradiation, in other words, solar power potential, infrastructure, transmission, distribution, power generation. This is one of the most challenging data sets to find in global, regional, and even national databases. That's why the collaboration with data providers, local data providers, such as the Ugandan Energy Sector GIS Working Group with members from the Ministry of Energy and Mineral Development, transmission, distribution, power generation companies, and others, contribute and own this particular initiative in the country. Other data beyond demand and supply, data, for instance, on environment, protected areas, data on finance service providers, microfinance service institutions. The platform will synthesize each and every data set, which becomes a criterion, and will help us come up with a prioritization map. Brighter colors indicate higher priority. Darker colors, lower priority. Priority based on what? Based on our unique perspectives. The unit of analysis here is 1 square kilometer. So for every square kilometer, you are able to get a different prioritization score based on our unique perspectives. What do we see here specifically in Uganda? We see high priority areas that are close to healthcare facilities, far from the closest distribution network, and where the solar power potential is significant. In other words, areas where solarizing healthcare facilities may be a viable option. Instead of spending a significant amount of time going through each and every square kilometer in the country, the platform will do this pre-screening exercise for us. There is a feature called top priority locations, which will give us a list of the top priority areas for energy interventions based on our criteria, not based on what someone else developed and we have to go with it. It's based on what we think as a stakeholder group is relevant for this type of prioritization exercise. So this is not a black box kind of analysis that someone else developed. This is something we are able to customize on the fly. So here we see an area which has been prioritized because we are close to a healthcare facility, the population density is significant, the solar power potential is significant. Still, we are far from the closest mini-grid and distribution network. Again, remember, you can utilize the satellite imagery to assess the situation on the ground. If we were to change the criteria, for instance, add agricultural productivity, the top priority locations will likely differ. This is what we see here. An area with agricultural activity, with settlement, with an education facility, with a road network has been prioritized for energy interventions based on the criteria we selected on the fly. What does on the fly mean? It means that you don't need to download any GIS software. All you need is access to an internet browser. Thanks to the granularity of input data, the analysis can be customized at different levels. So settlements, villages, wards, all the way to different administrative divisions, all the way to a nationwide analysis. This is what we refer to as inclusive planning, planning that happens at different geographic levels. A few words about EA's progress to date. The platform was originally prototyped in East Africa, in Uganda, Kenya, Tanzania, in close collaboration with local government agencies, research organizations, the likes of Strathmore Energy Research Center, Makerere University in the case of Uganda, Addis Ababa University in the case of Ethiopia, etc. Currently, it is being developed in 23 geographies at both national and subnational level. Partnership with over 200 stakeholders. This is collaborative initiatives, and all of you are welcome to be part of it. To date, there are over 23,000 returning users. Users that were previously left outside energy planning conversations are now equipped with a platform that enables them to generate a customized analysis. Thanks to its open source nature, we are exceeding in-kind contributions of 15 million USD. This is not the amount of funding that we've been able to raise. This is the amount of resources that would have been required if we were to rely on proprietary geospatial solutions otherwise. Spoke about the prototype countries. A number of countries have been added into the Energy Access Explorer mix, among which Nigeria, Ethiopia, and countries in Asia. A number of countries are also in the pipeline, among which Democratic Republic of Congo, Rwanda, and others. At the Africa Climate Summit last September, we had the opportunity to launch EA 2.0 with advanced features, functionalities, use cases. So in the EA 2.0 version, there are over 50 geospatial datasets that you are welcome to explore, combine, analyze, and also provide your feedback. You can get granular analytics, granular prioritization analytics without being GIS and market intelligence experts. But even if you are, you can save a significant amount of time from your day-to-day activities. You can extract the analytical outputs from a map view into a PowerPoint type of report, which you can use in policy documents, which you can use in business plans, which you can use in energy plans, etc. You can register and create My Energy Access Explorer. So you can save your analysis and you can run as many scenarios as you deem necessary. There is also a data management and a data governance system, which has been developed for data providers. This is what facilitates and promotes local ownership, which is critical for the sustainability of this particular initiative. If time allows, we can speak more about these two systems as well. A few use cases before I wrap up. In Ethiopia, the Ministry of Water and Energy, together with the World Bank and the utilities, are utilizing the Energy Access Explorer to inform the results-based financing scheme for off-grid electrification. What does this mean? Over 19 million people living in 145 waredas have been prioritized for off-grid electrification using a data-informed approach and using criteria that the local stakeholders selected. Not the criteria that a large consulting firm decided. This is a dynamic platform which is locally co-developed, co-owned. In the case of Kenya, we'll hear from Douglas in a while. The platform is being used to support the development of local county energy plants, together with Strathmore, together with local county governments, together with a number of partners. We support the development of county energy plants. This is Narok County. In a few weeks, we will be launching the county energy plan for Makueni. But we are also supporting the development, together with Strathmore and colleagues and partners, the development of the upcoming Kenya National Electrification Strategy. Some of you are on the call today. Another important use case, mapping data on productive uses of renewable energy. We piloted this in Bungoma, Makueni, Narok, so 3 counties in Kenya. We will be expanding and scaling this exercise across the country and across other countries as well. Why productive users? because they are critical for socioeconomic development in the region. In the case of Uganda and healthcare, we're working with the Health Ministry and the Ministry of Energy and Mineral Development to not only map the location of healthcare facilities, but assess electricity requirements. So how much electricity is required in unserved and underserved healthcare facilities. Why do we need this information? In order to be able to design viable supply options. Shall we extend the grid network? Shall we set up a mini grid? Shall we set up a solar home system, etc.? Similar exercise with the Health Ministry and the Ministry of Energy in Zambia while working on the development of the Powering Healthcare roadmap in close collaboration with partners. In Nigeria, we work with the Rural Electrification Agency. Nigeria is the #1 country in the world with unelectrified people, over 85 million people in a single country that remain without access to electricity. The Rural Electrification Agency is tasked with electrification of underserved and unserved communities. So we're working closely with the Rural Electrification Agency on the use of energy data and analytics to close the energy access gap. Close collaboration with a number of stakeholders in Tanzania, the Tanzanian Renewable Energy Association, TATEDO, and several others. And of course, the Energy Access Explorer Working Group. A couple of weeks ago, we released a practical guide on how the Energy Access Explorer can be used by clean energy businesses in Tanzania to identify market opportunities. Of course, the same exercise can be replicated across geographies, in Kenya, Uganda, etc. Also in Kenya, we've been working together with CCAK, the Clean Cooking Association of Kenya, the Clean Cooking Alliance, Ministry of Energy, and several other partners to add data and use cases focusing on the adoption of clean cooking technologies. We're working together with partners to inform the upcoming Kenya National e-cooking strategy, among other activities. One interesting statistic before I close is that 1 out of 2 users, almost 1 out of 2 users, are women. Why is it interesting? Because this is not necessarily the picture that we see in various workshops and conferences we participate. So here we are talking about equitable access to software, where a significant amount of stakeholders are benefiting from the open source nature of this particular initiative. We spoke about some of the national and subnational use cases. There has recently been international recognition. The Group on Earth Observations for Sustainable Development Goals awarded and recognized the importance of the Energy Access Explorer for achieving critical development goals, among several other recognitions across geographies. This wouldn't be possible without contributions from partners like Strathmore, from partners like the Ministry of Energy in Kenya, and over 200 partners, which I cannot name during this conversation. Let me pause here. I will pass it to my colleague, Douglas. This is just an overview. We would love to take you through this infrastructure in much more detail and organize trainings and take you through this when convenient for the members of IPA. Over to you, Douglas. Thanks for listening in.
Yeah, thanks a lot, Dimitris. So just allow me to quickly share my screen. And you can let me know if you can see it.
Yes, we can see it.
Okay, great. Yeah, so I'll just take you through a brief, quick demo on how the tool works. Like Dimitris mentioned, this is a web-based and interactive geospatial platform that you can use to visualize and overlay various geospatial data sets on energy demand versus supply, and carry out a multi-criteria prioritization analysis to identify locations that meet different criteria that you're looking for. So to access the tool, you'd need to go to a web browser. And for this particular tool, you need to use this URL. You can search for energyaccessexplorer.org. And the tool will basically take you to the landing page, like what you're seeing here on the screen, and you can be able to When you scroll down, you'd see a few tutorial videos that will guide you through how to quickly run through the tool, and also a number of blogs and publications around the tool that you can also read about to familiarize yourself with this particular tool. So yeah, just 1 second. Yeah, so for you to now go to the actual landing page of the tool, you'd need to click on tool. When you click on tool, it takes you to this particular interface where you'd see the number of different countries where we have this, or geographies where we have this particular tool with data sets for. And here you can see if you want to select maybe a country like Kenya, you can click on Kenya. Choose the Kenya geography right there, and then now you can be able to carry out or rather you get redirected to this landing page where on the left panel you should be able to see what we call the data control panel, or rather the control panel, where you can be able to add various kinds of layers. The middle section on the map shows the map interface where you can visualize whatever layers you add and carry out analysis on the same. And then on the right panel, you're able to visualize the summarized results on this. So for you to add a data set, you click on the first tool, on the first icon here on the left, and you can be able to see various layers categorized either as sensors. Sensors indicators what we got from the most recently conducted census on indicators that relates to energy, either for lighting. Say, for example, you want to add data set on lighting, what kind of sources for energy are used for lighting in different countries in Kenya. You can click on one of them. Like this one shows you the different countries in Kenya and what percentage of households use solar PV for lighting in this particular counties. You can also select any other layer, say lighting, electricity per county, and you'll see different results visualized. The brighter color shows you the counties with higher percentage of households using this particular fuel as opposed to the darker counties. This same analysis, or this same data set has been loaded here for cooking. So you can see different cooking solutions for different counties. And also information is also disaggregated up to sub-county level, where the same information can be seen, but now at a more granular level at sub-county level. So the other panel that I'd like to show you is on demand. So for demand, you can see these are basically data sets that show you potential demand for energy. It can be either demographics, like population density, like what you're seeing here is a map showing you at a square kilometer level, how many people live in one particular area at a square kilometer level. Again, the brighter color shows you areas where more people live as opposed to the darker colors. You can also visualize data sets on productive uses of energy. So areas that shows you where likely you would need demand for energy for social and productive uses. Like this is a layer for health facilities, showing you all the health facilities in Kenya. You can click on one just to get information about which kind of health facility it is, the name, the type, and also for every data set, there's additional information where you can see a more detailed overview of this data set and where we sourced it from, and a link to the source if that's available. And I can also show you one more layer, say schools. You can also add that, or crops, in case you're interested in agricultural use of energy. So on supply, we also have a number of data sets. We have data sets on the current existing infrastructure, like power plants. We have data sets on transmission and distribution lines. We also have data sets on existing mini grids, among others. And also for still on supply, we also have data sets on resources that can be exploited for energy, like solar potential. So this is a map that shows you the amount of sunlight being received at any given area per square meter. and also wind speed. You can see data set that shows you where there's high or low wind speeds. Those are areas which you can use, or you can extract information on this. So how will you use this data set? So for example, you'd want to say, if you want to look at areas in Kenya that you'd probably want to electrify, that has populations, that has maybe a health facility close by or a school close by, you can add this three combination of data set to show you demand for energy. And then if you are interested in now seeing of these areas that you've added, which areas have supply and which ones do not, so that you can prioritize on areas that probably do not have supply for energy, you can switch to the supply tab and add maybe distribution lines, because this one shows you the extent of the grid coverage in Kenya up to the point where it connects to the houses. You can also add data set on solar, on global horizontal irradiation, to see the potential for this particular resource being exploited for energy, in case the areas that you find that remain after you've done your filtering does not have is not grid connected. So all this data set that you can add in the tool, but now for you to actually see the actual results, you switched from data to analysis tab here. And then on the right panel, like I mentioned, you have summarized results. You can see the total population in Kenya before you do any filtering, and also the total area. So say, for example, you want to look at areas close to healthcare facilities and close to schools. You can now, below each data set, there's this filter where you can add either minimum proximity or maximum proximity. So if you want to add, say, narrow down to areas that are close to school, maybe if, for any area in Kenya that is at least 5 kilometers close to a school, you can change this maximum to 5. And then now the map would clip out or extract any area that does not meet this criteria and give you the result there, both in terms of the area that is covered in the map and also in terms of the summary statistics. You can also do the same filter for healthcare facilities. So I'll put a maximum of 5 there. And then again, the map narrows down to show you areas that first both 5 kilometers have a school within 5 kilometers and a hospital within 5 kilometers. So if you want to look at these same areas, areas that are far away from the distribution line, so you can either put whatever filter you'd like, say, for example, 2 kilometers minimum. So you say you're only remaining with areas that have a school and a hospital within 5 kilometer radius, but 2 kilometers away from the closest distribution line, meaning it's not covered by the grid. So you have, again, the map shows you these areas that remain and the total population that meet this criteria there. You can also say, of these areas that remain, does it have good solar irradiation? So the range for the global horizontal irradiation ranges from 500 to 2,800 kilowatt hour per meter square. So you can say you want to filter out areas that have maybe above 1,800, for example, as a minimum, or even 2,000. You'd see only areas that meet this criteria remain. And now you can have all these areas with over 3 million people that meet this criteria. And within this tool, you can narrow down to the top locations. So if I click on this icon, it shows you the top 20 results that meet your criteria. So for example, let's say you want to select the first one. The map will zoom to this particular point, and it will show you the reasons why this particular point was selected. So how the map presents these results is, again, by square kilometer, that shows you the areas that best meet this criteria based on the weighted analysis of all the layers that you've put in. So this particular area has been chosen because it has high population with 3,000 people. There's a health facility and a school close by. Then the solar irradiation is good, also 2,200, but the closest distribution line is more than 16 kilometers away. And the one thing about this tool is you can also overlay it with a satellite image just to confirm, or rather the analysis results, just to see what is below it. You can also select maybe one other point, maybe the second location, see how it looks like, and also the third location. The map just zooms in to different locations that best meet your criteria, and you can also reduce the opacity a bit just to see what is underlying this particular area, so that you can also narrow down to see certain populations at very, or rather, these particular areas at a very granular level. So this tool can also allow you to export results of your analysis. Say, for example, you want to export this particular information that you gathered from your analysis. You can go to report, and then you can get summary statistics of this, and you can export the presentation. Either it will generate for you a PowerPoint presentation, which gives you information on this particular area that you've selected. And it can also show you the kind of data set that you put in your analysis, and also the top 20 locations that are within your the top 20 locations that you can go to and do more detailed analysis if you want to carry out this particular or rather if you want to use for your electrification interventions. So I think I know time is going, but that's what I will probably share now. In case of any question, feel free to raise now. Yeah.
Yeah, thank you, Douglas, for the excellent demo. I think we have some questions running into the chat. Maybe you can voice the ones which have not been already answered by Demetrius. Maybe one I can catch here is that how does the tool ensure accuracy and completeness of the data? Are there mechanisms to validate this data and verify it? Maybe you can mention of how you collect and use the data.
Okay, sure. So, like I mentioned earlier, for all data sets that we add, say, for example, health facilities, we mostly source our data from credible, either government sources or international, global, or recognized databases that have or produce this data. And we list the source for every data set. So we first of all verify that the source is credible, and then we test this data out, and then once we're satisfied with it, we add it to the main platform. What I haven't mentioned is that we have different interfaces of this tool. One is the staging environment, where any new data set that we've come across, we test it there, validate it there, of course, with inputs from local stakeholders and partners to make sure that the data we have is credible. And once we're sure with it is now when we push it over to the publicly available website. But then again, we also get, we allow to get feedback from different users. So in case you have more updated data set from what you're seeing, or you have any question, you can always reach out to us. Yeah.
Thanks, Douglas. And also see another question here is, do you need special training to use the tool?
Not really. The purpose of actually one of the reasons we came up with this tool, like Demetrius mentioned, is to simplify the process of using geospatial platforms for data users and data providers. So that's why, like you've seen, this platform is very simplified. You don't need to be very highly technical user of GIS to understand and use this platform. But we do have training courses online that are in an online environment where you can actually quickly go through it. But we also organize very short, also in-person trainings. Maybe 2 days, you'd be comfortable to use the front end of the platform, and maybe another 2 days for the back end.
Right, thanks. And I can see Demetrius has shared the link. So Sabina, you can see the course is on open course certificate. All right. I don't know if there are any other questions. I would like to hand it over back to Dr. Wekesa to wrap up.